evening to everyone. I hope you are all doing well. So, we are looking at Learning Unit 3 in today's session. And I'm going to just be taking you through the questions that you see up on the screen. And as I said, this is the most effective way for us to get the session recorded, where I'll be sharing the screen with you and I will be writing on the screen. So, this is the only way that seems to work for everyone, where we are able to get both the audio and the writing on the screen. Crossing fingers that all goes smoothly since we had a bit of a difficult time last week. I do apologize for that. The new system has really been all over the place for everyone. So everyone's still trying to sort of find their feet with it, but I am hoping that this is the solution and it will work effectively. I've tried it out during the course of the last week and it seems to be quite effective. So here's hoping that this will go well. So, as I said, we're looking at Learning Unit 3 today, and the Learning Unit itself is split into two. So, I just want to explain that to you a bit before we actually start with the examples that you see up on the screen. So, firstly, as I had mentioned in my initial email for the semester and also in my initial lesson for the semester, my approach to this module in our live sessions is to work through examples with you, just purely because it is a numeracy based module, it is application based, and these are all questions from past papers that I work with during the sessions. So it really becomes obviously useful to you then instead of me just reading through slides, which you can honestly do on your own. It really becomes easier for you to see what a question will actually look like in an assignment or in an exam, and then have an idea of how to work through it, what we require in terms of how to set out a question or lay out an answer, and it just gives you a feel for what to expect in your assessments. So, all of the questions that I work through in these sessions going forward, and also last week's session, all are from past papers. They all are either a test that was previously written, or an exam that was written, or an assignment in the distance space. So, literally everything from an IIE assessment. So, really a good indicator of what you can expect. And this is why I prefer to work through those questions, because it gives you an idea of what to expect in your future assessments. So, this learning unit is going to be part of your assignment two. So, everything we've covered so far, last week's session and the learning unit one content, which is literally just purely theory, all of that is in assignment one, which you would have possibly seen so far if you've had a look at your assignment. And this is now forming part of your assignment two, and the learning unit itself is actually split into two parts. One of it is called your ungrouped data. That's the first section. And the other is your grouped data. So here it is going to be options in your assignment two and also in your exam. So this learning unit you're going to find will make up one section of your assignment and your exam, but they'll say to you, for instance, let's just say that this is section B, for example. They'll say to you in section B, there are two questions. Let's label that question 3, and that will be question 4. So they'll say to you in section B, there are two questions, question 3 and question 4. You will have to answer one of them, but not both of them. So it is entirely up to you what you feel more comfortable with. Honestly, most of the time, students choose ungrouped data because it's possibly familiar to you. You would have come across it before. You would have calculated some of the values that you see here. So it is a bit easier than the grouped data. In fact, a lot easier than the group data section, just purely because group data, although you're calculating the same things under both sections, it's just that the way in which the information is presented is a bit different. And group data just has more formulas that you'll have to work with rather than straightforward calculations as the ungrouped data section will have. So it really is entirely up to you. If you're up for the challenge in terms of group data, then that's perfectly fine as well. But whichever you prefer, I will be going through both of them. This week's session will be focused on the ungrouped data, and then next week's lecture will go through the grouped data. So, just so you know right from the start that this section will be one that will have options in your assignment as well as your exam, and you're aware that you do not have to answer both of them. So, without further ado, let's look at the type of questions. So, the learning unit itself is called descriptive statistics. So, once again, you will have to go through the slides on your own. The slides have absolutely everything that is necessary in terms of your assessments. They have a lot of examples in it as well. But again, that is not, I personally feel it's unnecessary to go through every single slide of those PowerPoint documents with you because, again, it's something that you can read through on your own and it has excellent examples. It's explained quite nicely, they're not complicated. They really are quite nice, the slides that are put together for each learning unit. So it's quite easy and user friendly for you to go through on your own, and I would rather focus on these examples and these application questions. So the section again is called descriptive statistics. And what we're looking at here is taking data that we've been provided with and condensing it into measures that can make it more meaningful. Meaning, instead of just randomly looking at data or being given data, information, or random values and looking at it and trying to gauge what information can we get from this, we take it and we apply statistics to it and make it more meaningful so that we can use this in decision making in the real world. So there are two approaches to descriptive statistics, and you'll see both ungrouped and grouped data will have these approaches. So you have a graphical approach where we'll be looking at two graphs that are generally uh, that you're generally asked to draw up, and then you have the statistical or the mathematical approach where we're actually now working out certain values or working out certain measures. So the graphical approach is where we look at two graphs. It's called your bar chart, which again, I'm sure you're very familiar with. I'm sure you possibly work with it very often. And you have a pie chart, also something that you would have definitely come across before. So I'm going to show you very quickly how to draw that up. And then we'll also look at the mathematical approach, which you will see is on the next page. So here's the mathematical approach, and we'll be calculating the values that you see up here. All right, so let's have a look at the graphical approach first, and then we shall work with the mathematical approach. So on the screen, it says to you, a researcher interviewed a sample of female consumers leaving a local shopping mall. The consumers were asked which brand of shower gel they used, and the results regarding the popularity of the shower gels are given in the following table. So in the table, you will see that they've given you the brand of shower gel, either Radox, Lux, or Dove. And then they've given you the count, which is also known as a frequency. So I'm just going to write that at the top here, the frequency or the count. And this is just looking at the number of female consumers that prefer each of those brand of shower gel. So 30 prefer Radox, 10 prefer Lux, and 20 prefer Dove. And this basically says to us that 60 people in total, 60 females in total, were asked which brand they had preferred, and that was the result. So, whether you're drawing up a bar chart or a pie chart, the same idea almost is applied. So you're going to always need this table given to you, this information given to you for both of them, for a bar chart and a pie chart. For a bar chart, it's quite straightforward once this table has been provided because all you're doing now is literally drawing up your bar chart. So I'm just going to scroll a bit here and you will see that, and I'm going to tell you how the marks are allocated for these because if I'm not mistaken, I think it's definitely included in your assignment too, either one of them, the bar chart or the pie chart. So the first thing that's important, and as I said, we're starting off with the bar chart, is that it must have a heading. So in this case, we're looking at the preferred brand of shower gel, so you could make that the heading. Honestly, here, there's no hard and fast rule in terms of the heading because each person might word it differently, but just look at, I would say, whatever the variable is that's being explained or that's being inquired about or surveyed about or whatever information was given to you in the table. So this is the preferred brand of shower gel. That will be your heading. And then you're going to draw up your bar chart. The category, which is in this case the shower gel, is always going to be your x-axis. So remember your x-axis is the horizontal one and your options are Radox, Lux, and Dove. Your count, and in this case, it is the number of female consumers, is going to be your y axis. And then in terms of your intervals on the y-axis, again here, it really is left to your discretion. If you look at the count, it goes up to 30, the highest is 30. So maybe you could work in fives. This would seem the most logical. So you'd go 5, 10, 15, 20, 25, 30, 35, and so on. We don't need to go beyond 35 because the highest is 30. But you can also draw this up on your Word or have it constructed on your Word document if you'd like, if you are familiar and comfortable with drawing these up on Word. But if you'd like to draw this up physically, freehand, and just incorporate it into your assignments, that's perfectly fine as well. The same goes for the pie chart. If you're comfortable with doing it on a Word document, that's perfectly fine. If you want to draw it freehand and just insert it into the document, that's fine as well. Okay, so the first one is Radox and it is 30. So you're literally just going to draw up a bar all the way to 30, which is here. And you're going to write the number 30 at the top. Then you have Lux, which would be 10. So this would be here approximately. And Dove is 20, which is somewhere here. And that is literally it. So the way in which the marks are allocated is there's a mark allocated to your heading. There's a mark allocated for your axes being labeled correctly. So having a label for your y-axis, having a label for your x-axis. And then there's a mark allocated to having these numbers on the bars. And also, the last mark comes from ensuring that you did actually draw up a bar chart and not a histogram, because a histogram does not have spaces between the bars, whilst a bar chart does have spaces between the bars. Also, very important, please make sure in your assignment, if the question does ask for you to draw up a bar chart, please don't draw up the bars horizontally like this. This is called a column chart, not a bar chart. So please make sure to stick to the one that you see up on the screen. This is what's required as per your textbook and as per the IIE memos. Okay, so this is your bar chart. I'm just going to pop into the live session chat just to check if there are any questions. You're also with me, also seeing the screen. Just a thumbs up is fine if you're good. Perfect. Okay, so let's look at the pie chart. So your pie chart, same idea, just a little bit more work that's required. So what we mean by a little bit more work is that with a pie chart, you're going to see that the information that was given to you in the table just needs to be added onto. So basically what you're going to do here is you're going to, sorry, let me just see if I can just erase that word. Perfect. Okay, so here you're going to add on to additional columns. So I'm just going to make my own makeshift columns here. And what we're calculating in these two additional columns is firstly the percentage of your frequency. So just converting that frequency or that count into a percentage. And then we need degrees because now we're working with a pie chart instead of a bar chart. So now it's the pie chart. So the percentage of your count is literally calculated by just taking your count itself over the total and multiplying it by 100. So 30 divided by 60 multiplied by 100 would be 50%. So this is 50%. Then 10 over 60 multiplied by 100. And here we're rounding them off. So it was 16.67%. And then 20 divided by the total of 60 times 100. Again, this would be 33.33%. Well, 333 recurring, but we'll round it off to the nearest whole, and that would give you 33%. So naturally, these would have to add up to 100% here, but you don't have to show that. And your degrees is where you are simply taking the percentage and you are multiplying it by 360 degrees because this is what a circle is, 360 degrees. So 50%, which is your first percentage, multiplied by 360 degrees is 180 degrees. Then 17% times 360 degrees is 61 degrees, and 33% times 360 degrees is 119 degrees. Now that we have the degrees, we can now draw up your pie chart. So with this, and I want to just let you know that you do not need to draw this up perfectly. If you're drawing it up freehand, you don't have to stress about having a protractor or compass or any of those to draw it up. You can draw it up freehand, just provided that it looks like it makes sense. So obviously we don't expect an oval instead of a circle, but if you're drawing it up freehand and you can make that circle look as circle as possible, then that's perfectly fine. But again, if you're comfortable with Word documents and you can draw it up on Word, then that's also perfectly fine. So here, and I'm just going to literally wing it and draw up a circle. In fact, let me see if there's any functions that can. No. Okay, so normal Adobe does allow you to draw up circles, but let's just draw this up freehand. Okay, so not the best of circles, but it looks quite legit. So here you are perfectly fine if you're doing this, just drawing it up. It looks quite accurate. Obviously, it's not perfect, but it's going to make sense once we show the respective categories. And then remember, if you draw a line down the center here and across here, remember these are all 90 degrees each. So use this as a central point, sort of, or something to refer back to each time you need to indicate each portion of the preferred brands here. So I'm just going to remove that because we don't need all of those now. So if you look at the first one, it's redox and it's 180 degrees. So since its circle is 360 degrees, 180 will be exactly half of it. So you can either, if you want, draw your line going all the way down here, or if you prefer, you can also do it across here, whichever you prefer. So this would be redox. And what you're going to include on this pie chart is the percentage. So you will put in the percentage of 50, not the frequency count, not the degrees. The percentage will go in here. In fact, if you do put in the count, it's fine as well. It won't be marked wrong, but generally it's a percentage that's preferred. Then the next one is 61 degrees, and this is lux. So again here, if you know that normally if we draw a line dead down the center here, it would be 90 and 90. But we need 61. So I'm thinking that 61 might be somewhere around here. So let's go with that. So let me just remove what I had here. And 61 should be somewhere around here. Okay, so let me do that again. So this then would be lux, and the respective percentage is 17. And then the last portion will be dove, which would have been 33%. And that's literally it. So those are your graphical approaches to your ungrouped data. Are we all still good? Any questions? All good. Okay, so let's look at now the mathematical approach, which I'm sure is the one that everyone is dreading. So here we have, and honestly, it's not too bad. The upside of this is that almost all of these formulas are in your formula sheet. So your assignment two, which you actually don't really need the formula for because it is naturally open book, but your exam will definitely have a formula sheet, and honestly, most of these are on the formula sheet. And most of the time, the most that they ask you from this learning unit, whether it is the grouped or the ungrouped data that you are selecting, it's going to be a 20-mark question. So the most that they can really ask you is about 4 or 5 questions from this entire learning unit, whether it's the group data or the ungrouped data. So although I am working through all 13 calculations and I also did the graphical approach, they realistically can only really ask you 5 out of these questions. And even then, part of it will possibly be the graphical approach. So I'm just going through it so that we have everything covered. But again, you're not going to naturally ever have to answer all 13 questions and the graphical approach as well. Okay, so let's look at these. So it says that the following data set indicates the number of inverters sold per week by an alternative energy retail outlet. And this was over a random sample of 11 weeks. Now, what's important to note here is that they said to you at the top that this is over 11 weeks. And this becomes your sample size. They actually use the word sample here as well. And this becomes your sample size, meaning that you have 11 values in total. So this is denoted by the letter N. You'll see it throughout this module. You'll see it in all of the learning units come up. We will always be referring to N, and N is always regarded as your sample size, meaning it's the total number of values that you were provided with. So again, you'll see here, if you actually count the number of values that were given to you here, it's 11 values in total, which just ties up with the fact that they told us again in that initial sentence that it is a sample of 11 weeks. So they've given you these values and they've randomly listed it out for you. There are 11 values in total, and what you can pick up from those values is that they are in numerical order. They're in ascending order from smallest to largest. So here, that makes it quite easy with some of the values that need to be calculated because the values are already in ascending order. You do not need to rearrange them. But sometimes you might get examples or questions where they won't be in ascending order. So one of the very first steps that needs to be done is to rearrange the values so that they are in ascending order. But this is already in ascending order, so we can go straight to your calculations. And the first one is the mean. So we're going to calculate them, and whichever ones do require interpretations, I'm also going to explain how they need to be interpreted. So the first question again is your mean, and your mean is also known as your average. So your average or your mean is literally averaging out your data set. Again, I'm sure you've come across this calculation before. You possibly work with it all the time. I mean, in our daily lives, we very often have to calculate the average amount we spent when we went to the store, that kind of thing. So it's just working out the average of the number of values that you see here. And that's just calculated by taking all of these numbers, adding them up, and dividing it by however many numbers there are. So in this case, there are 11 numbers. So basically, you're going to sum them up, and each value here is referred to as an X value. Each value is referred to as an X value. So when we talk about calculating the mean, it's denoted by the symbol X bar, and it's calculated by summing up all of the X values and dividing it by however many there are, which is the letter N, your sample size. So this symbol we saw last week means the sum of. So it's the sum of the X values, or the sum of all of your values divided by however many values there are. So here, when you add up all of these, 49 plus 64 plus 66 and 68 and so on, firstly, you don't need to show that. You're not going to need to show 49 plus 64 plus 66 plus 68 all the way up until 82 in your answer, whether it's the assignment or the exam. All you're going to do is show the final sum, which is 768, and then it's over your sample size, which is 11, and that gives you to two decimal places 69.82. Now, although this is based on the number of inverters that are sold per week, rightfully it should be a whole number because you're not going to get a decimal, but you are required to leave it as decimal format. Just for the purpose of your IIE memos, we don't want you to lose out on marks unnecessarily. So please leave them as a two decimal place unless the question specifically said to you round off to the nearest whole or round off to the next whole or whatever it is. So leave them as two decimals. And when you're interpreting, you could say that since your mean is your average, and again, there's no hard and fast rule in terms of interpreting here. You can put it into your own words. That's perfectly fine as long as the idea of the interpretation is there. So you're going to say here that on average, or you can say the average number of inverters, whichever one you prefer. Let's actually use that. Let's say that the average, sorry, let me erase that. So the average number of inverters sold per week is 69.82. So again, although it makes sense to be a whole number, you're not going to change that. You will leave it as is. So this is going to be your final answer and your interpretation. Okay, so that's your mean. And the next one is your median. So your median is known as the middlemost number in a data set. It's basically splitting your data set into two equal halves. So basically it's showing you, and if you just look at a normal number line, a median is exactly halfway through. It's separating the bottom 50% from the upper 50%, literally just splitting your data set into two. So here, sorry, I just want to delete so we have some space. Okay, so here with the median, it needs to be done in a three-step process. Now, what are the three steps? And please, again, ensure that you follow what we are showing you in these live sessions or what your textbook, if you're following your textbook or the slides show you. You have to do it in this way. Although you might know your own methods of doing it, you have to follow this way because this is how the marks are allocated in your memos. And unfortunately, if you don't stick to that, you will not get the full mark. You won't obviously lose out on all of the marks, but you're not going to get the full mark allocation because you would have left out certain aspects that are required. So with your median, the three-step process is if your data values are not rearranged in ascending order, then you need to rearrange the values. But again, here, as we said, they were rearranged for us, so we didn't need to worry about that. Then the next step is to calculate the position of your median. And with your ungrouped data, the position is calculated as n plus 1 over 2. The third step is now to actually determine your median. So here, let's look at these steps and how to determine your median. So for the first step, again, we don't have to worry about doing this because the values have already been rearranged. Second step is to determine the position. So here, remember our sample size is 11. So it's n, which is 11 plus 1 over 2. That's 12 over 2, which tells us that the sixth value in the data set is your median. And now all you have to do is just literally go to the sixth value. So this is 1, 2, 3, 4, 5, 6. And so you're going to say that your median is 70. So you've identified what your median is, and now you need to interpret it. So interpreting your median, you could say half of the time or 50% of the time, whichever you prefer. 70 inverters, and always say this, or less, always say or less, will be sold per week. Okay, so this is your interpretation of the median. So this is just showing you how to interpret, just an idea of how to go about your interpretations. As I said, you could have also, instead of the word half, you could have said 50% of the time because the median is also showing you 50% of the time what happens. So whichever you prefer, whichever you're more comfortable with. All right, then the next one is your mode. Now, in this example, you are looking for, and when it comes to the mode in general, you're always looking for what is the data value that is repeated the most often or the most frequently occurring data value. Now, in this example, if you look at the values at the top, there is no number that is repeated. So you are simply, and if you ever get this as an example, you will simply say that there is no mode. There is literally a mark allocated to that. So you will actually have a mark allocated to saying that there is no mode. So please make sure to write that down if you do have a situation where there is no mode. Okay, so let me just check the chat to see if everyone is still on the same page. All good? Okay, perfect. Can I just ask for 1 second while I grab a sip of water and we'll continue? All right, so let's get back into it. So our next calculation is the first quartile, which is number 4 here. And I've left whatever we did for the median on the screen, as you can see, because it's the same 3 steps that are followed for a quartile, first quartile, third quartile, and also here, if you look at number 8, it's called a percentile. So these 4 calculations, your median, your first quartile, your third quartile, and any percentile that you are asked, will always follow the same 3 steps that you see up here. It will always be rearranging the values, determining the position, and then calculating whatever it is, the median or the quartile or the percentile. So let's look at calculating this for your first, or carrying out these steps for your first quartile. So I'm just going to change 1 or 2 things here, which is going to be different. And let's take this all off from the bottom. Okay, so we are looking at your first step, which is to rearrange the values. So rearranging the values was already done here. We didn't need to worry about doing that. So let's take that off. Then the next one is to determine the position. Now, when it comes to the first quartile, which is the one we're working with at the moment, the position is calculated as n plus 1, but over 4. Now, in the same way that the median split our data set into 2 halves, your quartile split your data set into 4 equal parts. So basically, it's the first 25%, then you add on another 25%, so that would be 50%. Then you add on another 25%, that would be 75%, and then you have 100% of your data. So as you can see, it's 4 equal parts. So this is what quartiles are. They're looking at showing you the 4 equal parts that your data set is split into, and we are looking at calculating the first quartile and the third quartile only. So this is Q1, your first quartile. It's looking at the first 25% of your data. And then we're also looking at the third quartile, which is showing you 75% of your data. Okay, so let's go back to your question. So to calculate the position, we're going to say n plus 1 divided by 4. And so that's still 11. Remember, your data set has 11 values in it. We saw that at the top. And it's 11 plus 1 divided by 4, which is 12 over 4, which tells us that the third value in the data set then is your Q1. So Q1 then is 1, 2, 3. It is 66. So you have your Q1, and now you just need to interpret. So you will say, remember, Q1 is showing you the first 25% of your data, or it's the first quarter of your data set. So you could say a quarter of the time, or you could say, if you want, 25% of the time, whichever you prefer. So if you don't want to say a quarter, you can just say 25% of the time. And here we need to put in your value that you had calculated. So let me take out a quarter and just leave 25% there. So 25% of the time, 66 inverters still leave the words or less will be sold per week. So this is something that always needs to be included in your interpretation of your median and your quartiles and your percentile. As long as you're interpreting it, whatever the value is that was your median or quartiles or percentile, you'll always say that value or less. will be sold per week, or will be whatever it is, whatever variables they've given to you. So always include the words or less. So again here, 25% of the time, 66 inverters or less will be sold per week. Okay, so that's number 4. Now number 5 is looking at the third quartile. So the third quartile is also very, very similar to what we've just done. It is so similar that even the formula for the position is almost identical. The only difference is that instead of n plus 1, it's 3 multiplied by n plus 1. But please make note that the n plus 1 is within brackets and the 3 is on the outside, meaning you're saying that it's 3 multiplied by n plus 1. So same first step, rearrange the values. Second step is to determine the position, but this time, because it's a third quartile, the position is calculated as 3 multiplied by n plus 1 over 4. So it's 3 multiplied by 11 plus 1 over 4. So that's 3 multiplied by 12. 36 divided by 4 tells you that the ninth value in the data set is then your third quartile. So if you go to your data set, the ninth value is 75. So now you're going to say Q3 is equal to 75. And then again, you would need to interpret. So your interpretation, remember I showed you on the normal number line, is basically saying to you, this is the first 25%, then you add on 25 more, the next 25 will take you to 50, the next will take you to 75, and then 100% of the data. That was Q1, this is Q3. So Q3 is showing you 75% of your data set. So in your interpretation, you can either say 75% of the time, or you can even say 3/4 of the time. Again, whichever you're more comfortable with. So you can also say 3/4 of the time. I'll just stick to the one that we had here at the top. So 75% of the time, take your answer and plug it in here. 75 inverters or less will be sold per week. Okay, so again, the words or less must be included in your interpretation. So 75% of the time, or 3/4 of the time, 75 inverters or less will be sold per week. Okay, so that's number 5. Now, number 6 actually relates to numbers 4 and 5 that we had done here. Number 6 is called your interquartile range. It's just a measure of how far off your values lie from a central value. And the interquartile range is calculated quite simply. And I just want to erase whatever we have on the screen here. So let's remove all of this. So your interquartile range is quite simply calculated as the difference between the third quartile and the first quartile, meaning it's literally Q3 minus Q1. So we calculated Q1 just now, and that was 66. Remember, we did Q1 just now, and that value was 66. And we literally just calculated Q3, which was 75. And your interquartile range, which in short form is just IQR, is calculated as Q3 minus Q1. So this is Q3 is 75 minus Q1 is 66, and that would give you 9 as your interquartile range. And that's literally it. This one doesn't need an interpretation, so we're done with your interquartile range. The next one is your quartile deviation. Your quartile deviation is also dependent on that previous calculation and the two values before that. Your quartile deviation, for short QD, is just breaking down your interquartile range further in terms of spread, how spread out your values are. and it's your IQR divided by 2. So basically, it's the 9 that we calculated as your IQR divided by 2, which would be 4.5. And that is your quartile deviation. And that again does not require an explanation, so that is done. Okay, so again, let me just check in. All good on your end? Okay, perfect. So no questions, right? So let's continue. So the next one is number 8, which is your 65th percentile. So your 65th percentile, sorry, just don't mind me, I'm just neatening up in the meanwhile. So your 65th percentile, and remember I was saying to you just now, your median, your quartiles, and your percentiles is always calculated or following the same steps. First step is to always rearrange your values. Again, if that's done already, then you naturally don't have to worry about it. Step 2 is to determine your position. Here, the position is always calculated as P multiplied by N plus 1. And this is under ungrouped data, remember? And then the next step is to actually calculate the percentile. Now, this one does require a little bit more work than the others. So let's have a look at how it's done. Now, firstly, what is a percentile? So, like we saw, your median split your data set into 2 equal parts, so 50%, 50%. Then we saw your quartiles splitting your data set or splitting your data set into 4 equal parts, so 25, 25, 25, 25. And then your percentiles, literal to the word percent, are splitting your data set into 100 equal parts. So here, you can literally be asked to calculate any percentile from number 1 up until number 100. So you can be asked to calculate the 78th percentile, the 45th percentile, the 36th percentile, literally any number from 1 to 100. So in this question, we were asked to calculate the 65th percentile. So to calculate the 65th percentile, again, the values need to be rearranged. In this case, they are rearranged. We're done with it. The second step is your position. So P in this position is the number 65, but as a decimal. So that's 0.65. Basically, just take 65 and divide it by 100, and you'll get it to decimal format. So that's 0.65. So once you have that, it's multiplied by n, which is 11, plus 1. So the position is then 7.8. Basically, you're looking for the 7.8 value in your data set. Now, as you can see here, this is looking a bit different to what we saw with your median and your quartiles. So whenever you get a decimal, and you'll see that sometimes even for your quartiles, you might get a decimal, all you're going to do is firstly split that position. What do we mean by that? We mean separate the 7 from the point 0.8. The point 0.8 is basically 0.8. So separate the 7 from the point 0.8. The 7 is saying to you, go to the 7th value in your data set. So you'll count 1, 2, 3, 4, 5, 6, 7. The 7th value is 72. So you'll write down 72. Then to this, you will add on, open a bracket, and I would suggest using the square bracket like I am here. Then you'll take that remaining decimal, the 0.8, which as I said will be 0.8. It'll be always 0 before the decimal, so 0.8. And then you'll multiply this by the difference between that 72 you took from the data set and the number after it. So the number after it is 73. So it's 73 minus the 72 that you were working with. and that will be your answer. So remember, it's 7 in the position means take the 7th value from the data set. Then it says add on to this and open up a bracket, a square bracket. Take the decimal part of your position. And again, remember the decimal part of your position was 0.8, so 0.8. And multiply this by the difference between that 7th value that you had used here, which was 72. So in the data set, so just want to go to the data set and erase that. So in the data set, you had chosen 72. So the number after it, work out the difference between those two. So 73 minus 72, and that's what you're multiplying the 0.8 by. So when you put these onto your calculators, this will give you an answer of 72.8. So your final answer then is 72.8. So now to interpret, again, interpret it in pretty much the same way that you have seen for your median and your quartiles. All you're doing is saying, firstly, you're working out the 65th percentile. So you will say 65% of the time, 72.8 inverters or less. Remember always the words or less are sold per week. Okay, and that's your interpretation. All right, so this one, as I said, is a little bit different. And it is possible with your quartiles here as well, your first quartile and your third quartile, you could have also had decimals when you calculated your position, but it's done in exactly the same way. You always split that position into two, separate the first number from the decimals, and then the first number is telling you which value to go to in your data set, and then you'll add on to this, take the decimal, multiply it by that number you initially chose and the number after it, the difference between them, and then that will be your calculation. All right, so that's your 65th percentile. Then the next one is your range. So number 9 now is your range. This is a really easy and straightforward calculation. I'm doing it at the bottom here. The range is always calculated as the highest or the largest number in your data set minus the smallest number. So your largest number is the last number, 82, minus the smallest number is the first number, which is 49, and that is 33. It's also just a measure of how spread out your data values are. So that's number 9, your range. Then we have number 10, which is your variance. So your variance is linked to the next calculation as well, which is your standard deviation. They're both a measure of how spread out your data values are, how spread out your data set is, and they are linked up with each other because your standard deviation, which is number 11, is actually based on your variance. It's based on whatever answer you get from your variance, which you will see in a second. So for your variance, there is a formula that you need to follow. Again, you might have your own ways of calculating this, but please do stick to the method that I am showing you, which is also in your textbook and it's also what the IIE requires. So the variance is calculated using the formula, the sum of x squared minus n times your mean squared over n minus 1. So with your variance, what do these figures mean? So the sum of x squared, remember we said x is literally each value here that's been listed out. So what that's saying to you is you need to square each value and add them up. So basically 49 squared plus 64 squared plus 66 squared plus 68 squared plus 69 squared and so on. So you'll literally square each value and add them all up once you've squared them. So you don't need to show the whole long working out like I showed you at the top here. All you need to do is on a piece of paper, whether it's your assignment that you're completing or in your exam, if you're doing this question, just roughly on your question paper or just on a piece of paper if it's your assignment, write this out like I am here at the top, say 49 squared plus 64 squared and so on. So you know what you're doing and then work it out. You only need to put in the final answer. So when you square 49, and you can actually just put it like this onto your calculators as well. Your calculators will just literally allow you to say 49 squared plus 64 squared plus 66 squared and so on. So when you sum them up, it gives you a total of 54,400. Then you're going to subtract from that n, which is 11, remember? And then it's multiplied by your mean, which we did in question 1 was 69.82. So it's 69.82 squared. And then it's over n, which is 11 minus 1. So again, you can put this whole thing that we just wrote out onto your calculator. You don't have to do them in parts or anything of the sort. You can literally put that into your calculator with the use of brackets, as you can see around the 69.82. So type in 54,400 minus 11 and then open bracket 69.82, close bracket, square, and then over 11 minus 1. So this then will give you an answer of 77.68. And that's your variance done. No explanation needed for this one. Then for your standard deviation, which is the next calculation, it's literally as simple as the square root of your variance. So basically what we mean by this is you're just going to take the answer of your variance, 77.68, and find the square root of it. So that is 8.81, and that's your standard deviation as well done. So those two are linked to each other in that way that the standard deviation is just a square root of your variance. Okay, so the next one, coefficient of variation, is also sort of based on the previous one, which is your standard deviation, and also the first one, which was your mean. So your coefficient of variation, which is often written as COV, is calculated as your standard deviation over your mean, and it's expressed as a percentage, so it's multiplied by 100. So your standard deviation is what we just calculated now, 8.81, and your mean from question 1 was 69.82, and this is then multiplied by 100. So that will give you 12.62%. And again, that is your coefficient of variation. Okay, so no explanations for that one as well. And the last calculation then is Pearson's coefficient of skewness. So this is also a specific formula that needs to be used for it. The formula is in your formula sheet again. So for your exam, you don't need to worry about learning this. And this is the formula. So the nice thing about this formula is that most of the time, the figures that go into it have already been calculated. So if you look at it, it says 3 multiplied by the mean minus the median over the standard deviation. So most of the time in the prior questions, you would have calculated the mean, you would have calculated the median, you would have calculated the standard deviation. So let's calculate it here. So your mean is the first one we did. It was the 69.82. Then your median, we did second, and your median was 70. So this is minus 70. And then your standard deviation we did just now was 8.81. So now you have everything that goes into the calculation. And this gives you a negative 0.06. Please don't be alarmed if you do get a negative answer here, because it's completely possible, it's completely normal, it often occurs, and it's just because of how your Pearson's coefficient of correlation is interpreted. So, with this Pearson's coefficient of correlation, and you'll see this in your slides as well for the learning unit, there are three instances. It could be an answer that's equal to exactly zero, it could be greater than zero, and it could be less than zero, meaning it could be negative. So if it's equal to zero exactly, your interpretation will be that it is a symmetrical distribution. So this one does require an interpretation. If it is greater than zero, then it means your data set is positively skewed. And if it is less than zero, then it means that your data is negatively skewed. Your data set is negatively skewed. So in this instance, because we have an answer of minus 0.06, that means it is less than zero. So this indicates to us that our data set is negatively skewed. So you will state in your interpretation that therefore the data set is negatively skewed. All right, so that's it. That's all of the calculations that we have on this worksheet, all of the calculations for your ungrouped data. Are there any questions from your end? Are you comfortable with this? Lolita, I see that you had said that you wanted me to repeat how the zero point 0.8 is calculated. I think I did repeat it, but did you catch that, or you need me to explain that again?
It's fine. I'll listen to the recording.
Okay, perfect. But if you are still confused, please do let me know. I'm happy to explain that again at any point. Any questions from anyone else? So you will see that this is actually, as I said, the easier of the two. In terms of group data versus ungrouped data. Next week, when we look at your group data, it will sort of be a bit of a shock because some of the calculations that we looked at here today are it's exactly the same calculations, but there's so much more work that goes into it. There are formulas that are used. It is in your formula sheet, but it is a bit more work. So we'll look at that next week. But for now, you should be able to have gauged quite well what the first part of Learning Unit 3 is about. I naturally will make this worksheet available on ARC for you. Remember, I have created a folder that says live lecture content. So whatever we go through in these sessions, I'll upload there. But I also have additional revision worksheets that I will upload to the revision folder. I will also make this recording available as soon as we're able to download it. So I will let you know once it's available. Um, so Vanessa, your question about the index numbers, you will round up to two decimals. So 101.59 would round, well, 596 would round up to 101.60. So you will round up, but it will have to be two decimals. Please don't round them off to a whole number. All right, perfect. So then, if there are no other questions, we will end off here for today. Just for anyone that hasn't been able to see my announcements or not getting them as emails, please can I ask that you do set up the notifications for your emails. And also, I have recorded a session covering the assignment one, which I did upload to YouTube. And I also sent out an announcement to let you know that it is available. And I also included the link that will take you directly to the session. So if you do have any questions and queries about your assignment one, maybe just have a listen in on that. And in our next session, I will also just give you a couple of minutes at the beginning of the session to ask any questions or just look at any concerns that you might have in terms of the assignment. Thank you, everyone. Enjoy the rest of your evening and the rest of your week, and I will see you again next week. Cheers, everyone.